the three flow control mechanisms, that the stop, wait, and go back and selective repeat. So these are the different techniques for the flow control. So in this comparison table, we have talked about the efficiency for each of the protocols that we have discussed. So we should, on that time we said that to calculate the efficiency of stop and wait, we are going to use the eta. Actually, that is the n. So it has written 1 because n means here that sender window size. So in case of stop and wait, the sender window size is going to be always 1. And that's why it has written directly 1 here instead of n. Okay. So for the stop and wait, that the formula is for getting that the efficiency, eta equals 1 divided by 1 plus 2x. So that the x we are having here, the x is the ratio of the propagation delay versus transmission delay. So that means here to get the x equals TP divided by TT. So TP is my the propagation delay and TT is my transmission delay. So that is my efficiency for the stop and wait. And the go back, and you can see that it is n divided by 1 plus 2x. So that the 1 plus 2x is common for each and every cases. And also this n is common for this go back and selective and the selective repeat. So what is that the m means here? The m means here is that sender window size. So the sender window size for go back and is 2 to the power m minus 1. And in case of selective repeat, it is going to be 2 to the power a minus 1. So this is that the formula that you should need to be very much careful about, that for the go back it is 2 to the power m and then minus 1. And in case of selective repeat, it is going to be 2 to the power m, and with that m it's going to be minus 1. So that is that the difference you should need to be very much clear about. So this is what is going to be then what if you're finding that if you're counting here that okay that your n equals 4 for example, 3x for example, then it is going to be 3 divided by 1 plus 2x. So that the x is the same formula, that propagation delay and that the transmission delay. So this is also that n means here the sender window size and 1 by 2 1 plus 2 2x. So this is the same formula. Okay, but the window size, depending on the window size, you're going to be center window size, you're going to be place that the n value for both of them. So this is actually required for this example question that we are going to be face. So he's saying that if the bandwidth of the line is 1.5 mbps, so this is given the bandwidth, and RTT, the round trip time, is 45 milliseconds, and the packet size has been given 1 kilobyte. So bandwidth, RTT, and the packet size has been given to us, that actually we have listed here. So you say that then find the link utilization. So link utilization, other way we can set the efficiency. Okay, so it is asking that to find the link utilization in stop and wait protocol. So that is the fact here. And now we know that the formula for efficiency is going to be eta equals to 1 divided by 1 plus 2x. So that we have to find that the x value. So to find that the x value, we know that this is going to be my TP and divided by TT. So for finding the TP, the formula here is given the transmission delay. Oh, sorry, this is the TT, transmission delay, that is going to be packet size divided by bandwidth. Look that the packet size and bandwidth has been given to us. And for getting the propagation delay, that the round trip time has been given divided by 2. Okay, so that is going to be, you will be get that TP. So if you're getting that the TT and TP, then you're going to be get that the value of x. So if you're getting the value of x, then it is easily can be calculated that what is going to be the efficiency. So I would like to show you in a bit detail. So I am using calculator here. So here that, I mean, it's saying this is the TT, how you're going to find the packet size divided by bandwidth. So look here that we are going to be calculate this through that the millisecond. Okay. So if you want to calculate that the milliseconds, so we should need to be first convert this is to that the beats. Okay, so it is given that kilobyte, so you have to convert it to the beats, and mbps we have to convert it to the beat per second. So to do that, 1 kilobyte, usually we say that it is going to be 1024 bits. So that is represented with that the 2 to the power 10. You can see here 2 to the power 10, if you are if you are having, then it is going to be 1024, and we are multiplying. Yeah.
স্যার এখানে ইউনিট যদি চেঞ্জ থাকে এরকম কি হইতে পারে?
Yeah, then you have to do it. You know, need to be know that the units definitely. So you're getting here that 1024. So you're converting it to that the 8 bits. So multiply 8. So you're getting here equal to multiply 8. Sorry, what happened? 1024 1024 multiply 8. So we are getting here the 8192. Okay, 8192. That you getting? Sorry. Yeah, right. Exactly. Exactly. That is going to be 2 to the power 10 multiply 16 bits. Okay. All right. So now here you're getting that 8192. So next one is that you are getting that Mbps. So you want to make it with that the BPS bit per second. So that means it is going to be 10 to the power 6. Okay. So if it is 10 to the power 6, that is going to be 10 lakh 160, I guess. 10 to the power 6 you're having. So that you're getting here that yes, 6 zeros. So multiply, it is given the 1.5. So multiply 1.5. So you're getting here that 15 lakh. Okay. So this the 15 lakh, you're going to be divide this value with the 15 lakh. So write it 8192 divided by 160. Yeah, it was 15 lakh, right? Sorry, it was 15 lakh, right?
Yes, sir.
Isn't it? So if I'm dividing it, then I'm getting here, yes, correct. So it is going to be that 0.00546. So now you are getting here with that the beats. Okay, so you have to make it millisecond. Okay, the bits per second, it was second, so you are making it milliseconds. To get that the milliseconds, you need to be multiply with that the 1000. Okay, so if you're multiplying with 1000, you are getting here the 5.46 461. So it is taking 5.461 millisecond.
স্যার
Hmm.
স্যার এখানে আমরা এই যে 2 to the power 10 এটার সাথে আমরা 8 কেন স্যার মাল্টিপ্লাই করলাম এটুকু বুঝতে পারি না।
So you are getting that 2 to the power 10 means what? You are making it byte, kilobyte, right? 2 to the power
Yes
10
sir.
means 1024 byte. So you have to make it bits, isn't it or not?
Yes sir.
That's why you have multiply with the 8. Do you understand?
Yes sir.
So if it is that the 2 kilobyte, I think the Fuad was asking the question, right? Last time. So it should need to be multiplied with 2, right? Then we are going to be get 840 2048. That is going to be and multiply with 8 bits to get the bits. Fuad, can you hear me? You have asked the questions 2 kilobyte, right?
Yes, sir.
There.
Fuad Bhai asked.
Yeah, right. So this is going to be for byte to the bits. We are if you want to make so 8 bit equals what? 1 byte, isn't it or not?
Yes, sir.
Clear? Yeah. So that is a good question. So yeah, if you have any other things, you can tell. No. Right. Okay. So that means the next one is that the propagation delay, the TP, if you want to found, then it is going to be round trip divided by 2. So what is the round trip given? 45 milliseconds. So you're having the 45 millisecond divided by 2. You got the 22.5 milliseconds. So now you have got the TT and TP. So you can easily find out that what is that the X value is. So you can, for the TP, you found the 22.5 millisecond divided by you have got for TT the 5.461 millisecond. So if you just divide it, you are going to be get 4.12. So now if you are, you got that the X value is this. So now if you are finding that the efficiency eta equals 1 divided by 1 plus 2x, so you have just put the x values 4.12. So you're getting here that 8.24. and plus 1, so 9.24. 1 divided by 9.24, you're getting that 0.1108. So you're getting here that 10.8%, right? So you multiply with 100. Get it? That how to calculate that the efficiency or link utilization.
Yes, sir.
Okay, so this was that the last slide we are not actually discussing about. So from the first slide to the 38 slides that we have studied, and Mac we are skipping. We don't have time to actually go through them. And after that, actually, you have studied that error detection and correction. So from that 56 slide up to that the 71 slides that we have studied. So that these are the parts actually you need to study from the lecture number 8. Okay. So now we can go for that lecture number 9.
স্যার আরেকবার যদি একটু বলতেন, 38 পর্যন্ত পড়ছি স্যার আমরা, তারপর
Yeah, and
সাজেশন
that
দিবেন না?
error detection and correction, no suggestion. What is the suggestion? It's the final exam, right? The unique question we have to prepare. So there is not going to be any suggestion, and it has been said many times in the first term, midterm, the classes. Okay, so that we are going to discuss tomorrow. Okay, so we should not actually discuss unnecessary things. Let us first finish that the lectures, and then we can talk about the other things. All right, so I think you are clear now that the error detection, that was I said, that error detection correction, that we have studied everything from here on. Okay, so that the CRC, then that I mean the Hamming code, right?
ইয়েস স্যার,
Then
ইয়েস
that,
স্যার।
so you have studied all of them. Okay, so now we can move that the lecture number 9. So in the lecture number 9, this is going to be talk about the physical layer. So in case of the physical layer of TCP/IP encapsulation and decapsulation process, we know that there are 5 layers application. So we know that the header is going to be added with that the application layer, then it's going to be sent to the transport layer. From the transport layer, it is going to be come to the network layer, and network layer to the data link layer. So the data link layer, the frame we are having, that is actually going to be with that the digital data 0 and 1. So now in the when that is going to be at the header and tailor in the data link layer, that is going to be sent to the physical layer. So what is going to be the responsibility of the physical layer? To convert that the digital data to that the signal. So that is going to be actually in the TCP/IP is going to be happen. So that the conversion is going to be from the digital. So this is a digital data. For example, it is represented with 0 and 1. So this is an example. So after conversion, this that the signals that is going to be, I mean, data is going to be converted to the signals. Okay, the physical layer responsibilities converts the data to the signals. Okay, so this is the data that is going to be converted to the signals, and that is going to be sent to that the medium. So it can be that the wired medium, or it can be the wireless medium. Okay, so here we are talking about the data and that the signal, so that the both data and signal can be either the analog and digital. So to understand that the analog and digital, simply the data, in case of data, you can see that the analog data is going to be continuous form, and digital data is going to be discrete. So what is the continuous form? For example, that the watch you're saying, so if you want to move from the 10:10 to 10:11, so you need to be move second by second, 60 second, you should need to be move. So that is going to be a continuous process. You will be able to see here that is moving continuously. The second by second, it is actually going to be continuously move. So there is no jump that from 10 to 11 into this analogs data. But if you're looking to that the digital data, that is actually a digital clock, you can take into account. So you are having here the, for example, 10:10. Okay, for example, it is showing that the 10:10, but you will be suddenly actually it is going to be jump from 10 to 10, 10:10 to that the 10:11. So that is actually the discrete, and you can see that the here that the limited data is going to be there actually. Okay, that it is actually continuously moving, but it is a discrete one. Okay,
ইয়েস
and if
স্যার।
you're looking at the an example of analog data, so that is a microphone. Okay, that the sound made by human voice. So say that I am giving the lecture at this moment, I'm speaking, so that the what I'm speaking through that the wave, analog wave, it will reach to that the microphone, then it is going to be converted to the analog signal, and analog signal is going to be sampled and converted to the digital signal. The digital signal is then going to be that converted to the digital data, and that is going to be stored into that the computer as audio. Okay, so that the audio, video, text, all the information can be stored into that the computer with the combination of 0 and 1. So the digital data is going to be 0, I mean, with the combination of 0 and 1. So that the data you're having, that can be actually modulated or converted to that the analog signal, as well as it can be modulated or converted to the digital signal. So then based on that the medium, you are going to be transmitted. Okay, so this is that the an example of the analog data. Is it clear?
স্যার এখানে মডিউলেটেড মানে কি আর কনভার্টেড মানে কি?
The modulation technique, actually, that how the data is going to be converted to that the analog signal or digital signal. Okay,
জি স্যার। আর ট্রান্সমিশন অ্যাক্রস দ্য মিডিয়াম মানে কি স্যার? মানে এরপর যে ডাটাটা সেন্ড করে দেওয়া হয় মিডিয়ামের মাধ্যমে।
it is actually this one, your medium.
জি স্যার, জি স্যার, বুঝতে পারছি।
With air or with that the wire. Okay,
জি স্যার।
all right, so now that if you're talking about the signals, that you are having analog signal and digital signal, in case of analog signal, you can see that it is going to be a continuous wave form in nature and represented by continuous electromagnetic wave. So that is the main fact actually that is happening for analog signal. Okay, so electromagnetic wave, it is going to be converted to the electromagnetic waves actually if you're trying to convert it into the analog signal. So now that it has said that it has an infinite number of values along its path, and it's moved from a value A to that the value B. So this is actually is going to be in continuous manner, that like that the traditional watch we have seen. Then on that is said that okay, it has an infinite number of values. There can be the infinite number of values, and it's actually showing here that along its path as it moves from value A to value B, something like that. And if you're looking to the digital signal, that is the discrete in nature, we already said in case of data, and represent sequence by the voltage phases. So there are going to be the minimum number of values, as we have seen that that digital clock. So you can see that it's moving from A to B, something like that. So periodic signal not needed. So now you can come here the transmission impairments. What is that the transmission impairments is? It said the signals travel through transmission media which are not perfect always. The imperfection causes for the signal impairment. So what is that? And say that when a signal transmits from one medium to the other, the signal that is received by the received may differ from the signal that is transmitted due to various impairments. So what does it mean? It means that, for example, that cross-talking. So what is happening that okay, so that I am saying something, now I am saying that okay, I love Bangladesh. So I said I love Bangladesh. So it is going to be transmitted. I mean, it's going to be converted from digital to analog signal, so that the transmission medium is going to be sent to your side, and then that is going to be converted to that analog to digital. Okay, or maybe it is going to be digital to digital from center side, and in the receiver side also it is going to be digital signal to digital data. Okay, in my side it is from digital data to digital signal, and when it is reached on your point, that is going to be digital signal to digital data, something like that. So what is happening here, that the signal we are sending from that the sender side, that I said I love Bangladesh, for example. So now when it has been received by you, so you may the words may break. So maybe you could not hear that okay, I love Bangladesh. So you may not able to get that the whole message that what I have said. So that that is actually happening for that the transmission impairments. Okay, so there are various reasons that the transmission impairments can be there. So it means that what the sender is sending, the receiver may not able to receive it correctly. So that is the fact here, is that the impairments. So he said that consequences for analog signal, he said the degradation of the signal quality is going to be low. Definitely the degradation means that consequence for digital signal is going to be the bit errors. So that is the fact here. So impairment causes for the two reasons. One is the attenuation, distortion, and the noise.
স্যার,
Yeah.
স্যার মানে ট্রান্সমিশন ইম্পেয়ারমেন্টসটা দুই সিগন্যালেই হয়, অ্যানালগে হয়, ডিজিটালে হয়। অ্যানালগে হলো স্যার ডিগ্রেডেশনের মাধ্যমে হয়, আর ডিজিটালে বিট এররস এর মাধ্যমে হয়।
Yeah, the signal quality in case of the analog, the signal quality is going to be poor. It is going to be get down. Okay,
Yes, sir.
and consequence in case of the consequence that is actually for digital signal, there can be happen that with the bit errors. Okay,
Yes, sir. Clear.
so impairment causes for these three reasons. So what are the three reasons? Let us explain quickly. The attenuation here we are having, so sender is actually sending this the first point. Sender is sending these original signals and it is going to be transmitted over the medium. So in the point 2 you can see that because of the attenuated, the signal has been changed. It's not seen here. Okay, the signal has been not seen here. So this is what it said here, that when a signal travels through a medium, it loses some of its energy in overcoming the resistance of the medium. So for example, a wire carrying the electric signals gets over. So the signal has been changed. So that is why in case of that, actually to compensate for this loss, amplifiers are used to amplify the signal. So that you can see that here we are using that an amplifier. So through that the amplifier attenuated signal can be amplified, and actually you can get that the original signal that actually sent by that the sender. Clear?
স্যার এখানে ওই যে গেটস ওয়ার মানে কি বুঝাইছে স্যার?
What is the meaning of war?
যুদ্ধ স্যার।
The same, so that you understand, it is that war. Okay.
ওকে স্যার।
Yeah. So the same next thing is coming the distortion. The means that the signal changes in its form or shapes. Okay, signal changes its form or shape. So it can occur in composite signal made of different frequencies. Each signal component has its own propagation speed through a medium, and therefore its own delay is in arriving at the final destination. Differences in delay may create differences in the phase. So you can see here the composite signal in the sender side. So these are the in phase, that the phase signals you can see here, the components phase signals. So the phase signals from that the sender side, and the receiver side you can see that the phase symbol the components out of phase, in phase and out of phase. You can see that there is no change, but finally that when that receiver is going to be receive these signals, the composite signals, you can see that the signals are different. So the signals has been changed due to that the distortion, because of the different speed delay that the signal can be changed. So that is actually also a kind of a transmission impairments. If you're talking about the noise is the another cause of impairment. So you can see that due to the noise, actually there can be that different types of noise can be there: thermal noise, induced noise, crosstalk, impulse noise may corrupt the signal. So that is was the crosstalk I was given example just before, that what you are telling the sender is I mean transmitting, that is actually can be due to the noise that the signal can be changed. So look that what the receiver has received. Say that I have said I love you, then here he is saying maybe he is hearing I you, love is missing. So that is what actually the signal has been changed. So that is the what I mean. This is that the another reason that transmission impairments happens. So now we can go to that the digital data transmission here. So here we are having two types, the parallel and serial data transmission. So if you're looking to the parallel data transmission, so you can see that if I want to send that the 8 bits from the transmitter to the receiver side, so for each of the bit we need a single line. Okay, so that is what it is actually parallel. So that 8 bits are there, so that means we need that the 8 lines for transmitting that the 8 bits from the sender to the receiver side. But if you're looking to that a serial data transmission, then you can see that the transmitter is sending the 8 bits, but it is using a single line, and the bits are going to be transmitted serially, one after another. Do you understand that or no?
Yes, sir.
Right. So this is actually the serial transmission. So the main difference here is that in parallel, actually for each bit you are using a single line, but for all the bits you are using here a only one line for 8 bits, and here for 8 bits you are using 8 lines. Clear?
Yes, sir.
Yes, sir.
Okay. So now you can see that the serial data transmission here. All right. So that the serial that we are having the uh, no. Whenever the Fuad is asking some questions, okay, I am giving that the wrong answer. Okay,
Okay, sir.
Fuad. we are asynchronous here, and synchronous here is the parts of the serial. Do you understand that? The serial has been divided into two parts. Okay. So you are asking something in between that. I mean, I am getting confused. Okay. Last time that the question you have asked, that the answer you have got for the 2 kilobyte. Right, right. So that 1024 is going to be that 1 kilobyte equal to that 1 byte. Okay, 1024. So if you are having the 2 kilobyte, then what is going to be happen there? 1024 multiply 2, and then you are getting bytes. Then you have to multiply it with the 8 to get the bits, isn't it? Yeah, so that is the fact that works. All right. So is it clear that, I mean, the parallel and serial is clear here, right?
স্যার এই অ্যাসিঙ্ক্রোনাস আর সিঙ্ক্রোনাস দুইটাই সিরিয়ালের পার্ট স্যার নাকি?
Yeah, yeah, yeah. You can see that it's actually shown here. I think I have marking
sir.
marking here. So you can see that for the serial, it is showing here that serial. This is having the two parts. Okay.
Yes, sir.
So now let's see that what is the synchronous and asynchronous. So in case of the synchronous transmission, what is going to be happen is, say that sending bits are not sending bits are one after another without an start or stop bits. So there is no significant flag, or there is no significant thing with that the bits, that by seeing that receiver will understand that okay, these are the 8 bits 1 byte. In this case, actually the receiver is responsible himself that to actually count the bits, that from one, say that 0 1 2 3 4 5 6 7. So when he's counting the 8 bits 0 to 7, so he is actually taking is a 1 byte. So that this is the way the receiver is actually responsible for counting the bits and making the byte, and 1 byte to the another byte he should need to be actually separate. Okay. So this is what it's saying, the sending bits are one after another without start and stop bits of group or gaps, and say that it is the responsibility of the receiver to group up the bits. Okay. I say the receiver counts the bits as they arrive and groups them into 8-bit units to get that the byte. Clear? So you can see that it is sending the values something like that: 0 1 2 3 4 5 6 7, 0 1 2 3 3 4 5 6 7, 0 1 2 3 4 5 6 7, something like that. 8 bits, 8 bits, 8 bits is going. So it's counting that is 1 2 3 4 5 6 7 8. So when he find the 8, so he takes as a single byte. Then again he start count 1 2 3 4 5 6 7 8. So now he's at 7. So now he's actually counting the 8 bits. 8 bits, 8 bits, 8 bits. So that is how that actually he's separating byte by byte. Is it clear that what is the synchronous?
Yes, sir.
So if it is the asynchronous, in case of the asynchronous, what is happening, that is going to be use the start bit and stop bit. Okay, and that the data is going to be in between them. So what is actually is happening here, that you can see that there are three types of bits have been used here. One is that the ideal bits that is actually represented with 111. So that is kind of a pause, you can think like that. Okay, there is a pause. So it is using that a start bit 0 with the 0. If it is after the pause, if that the receiver is seeing that there is a 0, he will understand that okay, this is a start bit. 0 is a start bit, so this is the 0. 0 is a start bit. So now he is actually going to be count that 0 to 7, 1 2 3, sorry, 0 1 2 3 4 5 6 7. So these are actually that the original data byte. Okay, original data bits. So these are the original. So these are the original data bits are going to be synchronized. So it is going to be synchronized itself. But we are actually using that one start bit and stop bit. So before sending that the synchronized 8 bits, we are actually using start bit, and end of that the synchronized 8 bits we are using a stop bit. Okay, so there is going to be start bit and stop bit, and with that actually receiver by seeing the start bit and stop bit, he will be able to understand okay, this is my data, the 8 bits. After the stop bits, start bit, that the data bit started, and before the stop bit, the data bits ended. Is it clear?
Yes, sir. তাহলে কি স্যার এটা রাইট থেকে লেফটের দিকে ডাটাগুলো বিটগুলো রিড করতেছে না স্যার?
Yeah, this is going this way. Okay, sender to receiver. So this is what the receiver is receiving. So 0 is receiving as a start bit.
Yes,
Then
yes.
he's getting the data. Okay, and then after counting, when he see that the stop bit, he is going to be understand okay, this is my 8 bits of data. Understand or not?
জি স্যার।
So, and then actually you can see that there is an idle bit. So with that the idle bit, so that this is a kind of a pause. Okay, that after one byte, another byte you're sending, so there is in between a pause. So with that the pause receiver will be able to understand, I mean separate that byte to byte. Okay, so that is the asynchronous transmission. So here it says that asynchronous means asynchronous at the byte level, but the bits are still synchronized, then that the duration are same. Okay.
ইয়েস স্যার। স্যার এখানে চিপ এন্ড এফেক্টিভ লেখা স্যার, অ্যাসিঙ্ক্রোনাসটা যদি অ্যাসিঙ্ক্রোনাস থেকে কিভাবে এফেক্টিভ একটু শর্টলি যদি বলতেন।
Yeah, it is going to be effective as because you know that, I mean the it is actually, if you're trying to comparing with the synchronous transmission, right? Look that here you are just simply sending the beats. Okay, so there is no stop and start beat, there is no that any pause, just you're simply sending 0 1 2 3 4 4 5 6 7 0 1 2 3 4 5 6 7 0 1 2 3 4 5 6 7. So that is actually, there is no separation, no nothing is there without the beats, without the beat data beats. So what the receiver is trying to do, the receiver is actually has the responsibility to count each of the bits, that 0 1 2 3 4 5 6 7. So now he's actually grouping it and making it a single byte. Then again he's counting 0 1 2 3 4 5 3 4 5 6 7. So the receiver has actually the more responsibility here. Okay, so
ইয়েস।
but in case of the asynchronous, what is happening, that you are using that the start and stop bit, and with that actually you are making it asynchronous. The synchronous data actually making it asynchronous with that the start and stop bit. So the receiver actually has the less trouble here. Understand?
ইয়েস
So
স্যার, ইয়েস স্যার।
these are the kind of a flag, that stop bit and start bit you are using. So he's just maintaining the flag. So if he's saying that the flags, he understand that in between I'm having that the 8 bits data 1 byte. So actually it is easy for him to separate. Okay, so that is going to be definitely effective. Understand?
ইয়েস স্যার, ক্লিয়ার।
Mm. Idle bit is going to be automatically there after the stop bit. Okay, so this is a kind of a pause, as I am saying. Okay, and there is going to be a pause, right? So that mean that, I mean I'm talking. So when I'm telling a sentence, after that I'm taking a pause, and then again I start something like that. Okay, so if I'm not taking the pause, then it's not going to be maybe understand much understandable by you. If I'm not having any pause, if I'm just speaking and speaking and speaking, then you're going to be lost definitely on it's going to be definitely like that, isn't it or not? Right, exactly. If there is, you are not sending anything, then the beats data beats, understand or not? You're not using anything rather than the bits, the data frames bits. Okay, so but here you are having the stop bit and start bit, and with that actually it is going to be easy to receiver. It is going to be easy for receiver to understand that, okay, this is a group of, this is a frame, 8 bits frame, and he is actually separating it with another frame. Is it clear or not? Right. So now we are going to be talk about the different conversions or transmission scheme. So we already said that data or information can be stored in two ways, that analog and digital. So there are different conversions methods. We are having digital to digital conversions, analog to digital conversions, digital to analog conversions, and analog to analog conversions. So if you're looking for that those conversions methods separately, that digital to digital, it covers the line coding, block coding, and scrambling. These are the schemes. And here we are having analog to digital like PCM, PAM. And in case of the digital to analog conversions or transmission scheme, you can see that ASK, FSK, PSK, these are actually very popular methods, QAM. And then you are having that for analog to analog, that we are using AM, FM, PM. Okay, so these are the different conversion methods, and these are the different schemes for those methods. Okay, so now from these out of these all the conversions methods, we are going to be study only this part. Okay, that digital to digital conversion. So that actually we are moving that what is the digital to digital encoding. So it says that digital to digital encoding or conversion means convert the digital data into digital signals. Okay, convert the digital data into digital signals. Okay, so when actually you are sending something, so say that your digital data is need to be converted to the digital signal, like that peak, like that 0 1 peak. Okay, and then when it is going to be received to the receiver, so that need to be converted signal to the data. Okay, so this is actually known as the digital to digital encoding, or this is called that the conversions, digital to digital conversions. So here we can see that the conversion involves three techniques. This example is here actually in the next slide, so you'll be able to see that the conversion techniques are here, like the line coding, block coding, and scrambling. And out of these three, this one is actually most of time we are using the line coding. So you say the line coding is always needed, but block coding and the scrambling may or may not be needed. So that's why.
Sir, your voice is not coming clearly.
How about the others?
Clear.
Is it okay? And other students, for other students?
Yes, sir. Yes, sir.
Yes, sir, it's okay.
So that means she is facing some internet issues. Okay. So here that we are going to be out of these three techniques, we are going to be talk about the line coding, because this is actually always needed. Okay. So these are going to be only focus in our lecture now. So that the line coding means what? It said line coding is the process for converting digital data. So that digital data is going to be with that binary form 0 or 1 to the digital signals denoted by the discrete signal. So it converts a sequence of bits to a digital signal, of course, at the sender. The digital data are encoded into a digital signal, and at the receiver, the digital data are recreated by the decoding the digital signal. So you can see that the sender is sending that the digital data, so that must need to be converted through the encoder to that the digital signal. So that the digital signal has been transmitted over the medium. So in the receiver side, when it is received, so these digital signals must need to be converted to that the digital data. Is it clear now?
Yes, sir.
Yeah. Again, I did not get. Yeah, recreated means that, I mean, that the original data has been sent, the digital data. তাই না? তুমি সিগন্যাল থেকে রিক্রিয়েট করতেছো, কি রিক্রিয়েট করতেছো? দ্য ডিজিটাল ডেটাকে তো তুমি ডিজিটাল সিগন্যালে চেঞ্জ করেছো, তাই না? So you are actually recreating the digital data from that digital signal you are receiving, the receiver side. Okay, so you can tell in that the I have changed it with the I did not say recreate in my lecture. You can tell it in a different way. You can tell that the digital data, the sender side digital data, before transmitting it must need to be converted through the encoder to the digital signal, and the receiver side, when it is going to be receive the digital signal, that must need to be converted to the digital data. So this is what I said, and what it is written here, it's same. Is it clear?
Yes, sir.
স্যার স্যার একটু শর্টলি যদি বলতেন যে সিগন্যাল আর ডেটা দুইটা কি জিনিস বা দুইটার মধ্যে কি পার্থক্য?
So we have already said that what is the difference between the data and signal, that actually we started with, right? So that
Yes,
what is that the analog and digital data, and what is that the analog signal and digital signal, we have already explained it. Understand?
ওকে স্যার, ওকে স্যার।
Yeah. Okay, so now we are having that the digital to digital encoding, also known as the line coding. Okay, so that the digital to digital encoding or conversion we are talking about, that is also known as the line coding. So what is that the line coding consist of? We are having the unipolar, we are having the polar, and we are having the bipolar. So that the polar we are having, that has to be divided into three categories. One is the non-return zero, NRZ, and then return zero, RZ, and the biphase. And non-return zero has the two parts. One is the NRZL, NRZI, and this is the return zero. Biphase we are having, that is actually two categories, Manchester and differentiate Manchester. So these are the three techniques we are going to be studying now, that unipolar, polar, and bipolar. So unipolar cases, what is happening? The digital transmission system sends the voltage pulses over the medium links such as wire or cable. Unipolar encoding using the single voltage level to represent the data. One, to represent the data 1. Single voltage level to represent the data 1 is unipolar encoding uses single voltage to represent the data. 1 is considered as high voltage, and 0 is considered as the 0 voltage transmitted. So this is actually representing with that the 0 and 1, right? For what? Unipolar encoding uses single voltage level to represent the data. Okay, so it is either going to be deal with that the 1 or 0. So if it is 1, there is going to be the high voltage, and if it is 0, that is going to be the 0 voltage or neutral voltage, you can say. So it can travel only through the media which can handle DC component. Okay, so if you are looking to this point, it is going to be clear into this example figure. So we are having the amplitude here, and we are having the time here. So now this is the data I have given, 0 1 0 0 1 1 0 0, and you are seeing the dotted line. So for that, this is actually a period, time period.
But we are giving the numbers randomly, right?
These numbers are actually that the data. Okay, it can be any numbers with that the 0 and 1 combination. These are actually your data. Understand or not?
Yes, sir. Yes.
Yeah. And the dotted line you are seeing, for that each bit actually you are having a period, the time period. Okay, so now you're sending that the data. So you have said here that if it is 0, then you are going to be neutral 0, so that the that it started with 0, so you can see that it is neutral. It is neutral 0. What is the color? Where is the color? Comment. Color. Light text. Okay, I think let's continue with this color. How I forgot that how to change the color.
স্যার হোমে ট্রাই করতে পারেন স্যার, হোমে।
Should be here, but distance, yeah, comments show on import, select. Here it should be the comment line. This is one. Okay, so now you can see that, I mean, it started with 0, so that is the neutral. Okay, that is the neutral, you can see. And he said that if it is 0, then it's going to be neutral or 0 voltage transmitted, and if it is 1, then it's going to be the high voltage. So that you can see that the when it get 1, then it's go to that the high voltage. Okay, now again it get 0, so it is going to be move on neutral. Again it's get 0, so it is going to be move neutral. And then the 1 it gets, so it is going to be get that the high voltage. Okay, 1 means high voltage. And then again it is get 0, so it is going to be get the neutral. Do you understand that? So with that the 0 1 combination, you should need to be checked that if you find 0, that is going
Yes,
to be
sir.
go neutral. And that if it is 1, then it's going to be go to the high voltage level. So that is actually your unipolar encoding. Clear?
Yes, sir.
I can hear you. Yeah, look that, I mean, it is going to be depend on that actually. I mean, uh it, that some places you need that digital conversion. Okay, some places you need that the analog conversion. So you should need to be understand that the digital devices and analog devices, so that the medium we're talking about actually, this is that in terms of the communication. Okay, the data communication. So whatever you're going to be need that the digital to digital conversion, that you're going to be do there, right? For example, that radio transmitting you're doing. So actually what you're using there, FM, right? Frequency modulation. So actually depend on that the application depend, you are going to be use this techniques, the conversion techniques. Understand or not? So different communication system requires the different encoding systems. Different that's why we say that it is digital to digital encoding. Let's say we say that digital to analog, analog to analog, analog to digital, right? So based on that actually, in which data communication you are going to be use them. Okay. So this is what that we are having here, the unipolar one. The unipolar one is almost an obsolete method today. So we are not actually using this method anymore. So that is that the we are moving now to that from unipolar to the polar. Okay. So if you're going to that the polar, so you can
Sir,
see that.
what is DC? DC, sir?
Yeah, the DC component. It means that actually you are transmitting that uh, and networking. So say that satellite to satellite. Okay, so these are that the your that the medium you are going to be
Yes, sir.
using. Okay, so that is actually this is going to be work. This one actually going to be work only for the DC component. Okay, that the unipolar. Do you understand? The components must need to be
Okay, sir.
okay. So now here that if you're going for that the polar encoding that uses the multiple voltage levels to represent the binary values. So here we are going to use the multiple voltage levels. It uses actually the two voltage levels, positive and negative. I say that by using the both levels, the average voltage level on the line is reduced and the DC component problem of unipolar encoding is alleviate. So that the DC component problem was there into that the what is that unipolar encoding scheme that has been actually reduced by using that the polar encoding system. Okay. So in that the
Yes,
polar
sir.
we are getting the different methods that we are having the non-return zero. So we have already discussed. So we are going to be studying one after another. Let's start with that the non-return zero, that NRZ encoding. It said that it uses the two different voltage levels to represent the binary values. The level of signal can be represented either positive or negative, and it does not return to zero. So that is the main fact here. That's why the name has been given non-return zero encoding scheme. The two most common methods used in the NRZ transmissions are the NRZ L means here the level of the signal, and then NRZ is the inversion. Signal gets inverted. So what is that the NRZL? It said depends on the type of the bit that it represents. If a bit is zero, voltage level is going to be positive. If it is zero, and if it is one, then voltage level is going to be negative. Okay, so therefore it said the level of the signal is depend on the state of the bit. So NRZI, that is the signal gets inverted. So NRZI is an inversion of the voltage level that represents one bit. So a transition occurs between that the positive and negative voltage that represents one bit. Zero bit represents no changes. If you're finding that the zeros after zeros, so that the voltage level is not going to be changed. But if you're getting one, then the voltage level is going to be changed. I mean, first one you get, if it is positive, then next time you're getting one, that is going to be negative. Again, one you're getting next time, then it is going to be positive, something like that. It is going to be clear. It is going to be clear with these example figures. So you can see that we say it in case of the NRZ L, we say that if it is a zero voltage, the voltage level is positive, and if it is a one voltage, that is going to be negative. So there is nothing is going to be returned to zero. So this is my zero or neutral voltage. So that is not going to be moved to that. That's why it is non-return zero, first of all. And the second is that if the zero, then it is going to be positive. So you can see that it start, this is my data values, that 0 1 0 0 0 1 1 1 0. So you can see that it started with 0. So this is my positive voltage. So 0 means that the voltage level is positive, and then we get 1. So 1 get means what? 1 means that the voltage level is negative. So we are going to move to that the negative. Okay, so now you are getting that 0 again. So if you are getting 0, then it's going to be positive. So now you got the 0 again. So the it's going to be move on with that the positive. Then you get 1, so it comes negative. So now you get 1 again, 1, so it's going to be continue again, 1 is going to be continue, and then 0, it is going to be positive. Do you understand that? Is it clear? It's so simple that if it is 0, that is going to be in that the positive side, and if it is 1, then it's going to be into the negative side. So that is the fact actually. Is it
Yes,
clear?
sir. Clear.
It is easy. And if you're looking to that the NRZI, what is going, it say that if it is the zero bit, there is not going to be any change with that the sequence of voltage levels. Like that, if you're starting with the 0, look that if it is 0 bit, it says that, I mean, there is going to be no change. So that it is that the started with the positive. Okay, that the 0. So now you get 1. So if you are getting 1, what is going to be happening? It said that 1 bit represents a change in the voltage level. So you are in the positive, right? You are having in the positive at this moment, so that 1 is going to be taken into the negative. So now you get 0. So if you get 0, there is not going to be any change. That is said the 0 bit represents no changes. So that means it is going to be stay into that the negative. It is going to be go on. Okay. Again it's got 0, so it is again going on. So now you get the positive. Okay. So with the 1 you came negative. Now you get the positive. So that is going to be take you up. Understand or not? So now look that again you got the positive 1. So that means you are in the positive. Now you are going to be moved to the negative. So the transition is going to be happen here from positive to negative, negative to positive, when you're going to be get the ones, one after another one. Okay. So now you get again 1. So look that from negative it come to the positive. And now it's 0. So there is not going to be change. It is going to be move on. Do you understand that or not?
Yes, sir.
Yeah. So this is what that why it is said that energet. Look that we have never gone to that the non I mean the 0 level or neutral voltage level. We have never gone. We are either up or we are in down, but we never got back to that the neutral 0. Okay, neutral voltage or 0 voltage.
Yes, sir.
Yeah. Okay. So yes, they say that it is NRI is used in the USB complex CD and fast Ethernet. Okay. So next one is that the return 0 RZ encoding. So there must be a signal change for each bit to achieve a synchronization. So that is a challenge. However, no changes with every bit. Sorry, to change with every bit, 3 values are needed. So now here it is using the 3 values like that the positive, negative, and 0. So the positive voltage represents for 1, negative voltage represents 0, and the 0 voltage represents none. Okay. So these are the 3 voltages are going to be used into that the return 0. So that means it is going to be returned into zeros. I mean, when every time that actually it is moving with 1 or 0. So let's see that how it is going to be done. The signal returns to a resting state called 0. Okay. The signal returns to a resting state called 0 during the second half of each bit. During the second half of each bit. So that means we say that this is that the period, right? So in the half of that is the half it's talking about that during the second half of each bit, it is going to be go for resting state. So that the resting state is actually your 0 voltage. Okay, so say that in other words, the halfway go through each interval, the signal returns to 0. So that is the fact actually I said. It is going to be clear if you are seeing the next slide example. In RZ transmission, the signal changes not between bits but during each bit. Okay. So RJ scheme uses self-cognition. So here one thing that you can see that I mean that this is dealing with that the full period. Okay, so that all that the schemes we have discussed now, it is actually using that the full period of for a bit. But in this scheme, it is going to be use a half period. From that the period it is going to be use that the half period. So that you will be able to see here that with the return 0, 1 bit if it is there represented by positive to 0, and 0 bit is represented by negative to 0. So you can see that for that the 0, it is if it is 0, then what is said negative to 0. So you are going to that negative and you're coming half state and you are saying that 0. Okay, so 0 is in your neutral. You are returning to 0 after half of that the period. Okay, so you are coming from negative and you are uh, returning to the 0. So the next bit is 1. So that the 1 is representing positive to 0. So that is you can see that you are moving from positive and halfway you come and then you are resting state. Okay, return to 0. So now you're getting again 0. So you're coming down and this is actually you are negative going negative to positive. Sorry, yeah, negative to 0. And then this is the resting state, right? Then the 0 state. And then again you're getting 1. So you're moving to that the uh, if it is 1, then you are moving to the positive to 0. So you are having that the positive to 0. Do you understand that?
Yes, sir.
Yeah, so there is an easy way that you can actually remember it like that. If you're seeing that this is a jet with the jet form, then it is going to be positive. So positive to 0, that is means 1. If it is the reverse jet, So the reverse z is going to be like that. Okay, so this is going to be 0. So you can see that when it is going to be negative, so you are going to be with that the reverse z. Okay, 0 means here that negative to 0, so reverse z means negative to 0. So now you can see that for 1 bit the uh, your correct form of z. Okay, so you have to connect that actually. After adding that the z, you have to connect it with that the previous one. So now you are having that what next to what you are having, that is the 0. So what is the 0 means? The reverse z. So you can see that this is the reverse that you are having here. Okay, you are just now connecting it. So now you are having that the 1, so that means it's going to be correct form of that. So this is your correct form of that, and that is going to be you connect with this. Is it clear?
Yes, sir.
Okay. So now we can go for that the biphase. Best solution to the problem of synchronization is that the biphase encoding. And it is an encoding scheme in which signal changes at the middle of the bit interval but does not return to 0. So it uses the self-clocking. So here it is the implemented in two ways, the Manchester and differential Manchester. So in case of Manchester, what it does, it's making the combination of the two schemes. One is that the return 0 and non-return 0 level. Okay, so it is said the bit time is divided into two halves. It transmits in the middle of the bit and changes the phase when a different bit encountered. In case of the differential Manchester, this encoding is a combination of RZ and NRZI. So you can find it out that actually what is the difference between the NRL and NRI, NRZI, NRZL and NRZI. So you can see that in the NRZL it was combination of RJ and NRJL, and in the case of differential Manchester it is RJ and NRZI. They have combined these two schemes. Okay. So in this case, it said it also transmitted the middle of the bit, but changed the phase only when one is encountered. Okay, so now you're going to see the example. It is going to be clear. So for that, the Manchester, you should need to be use these two forms. Okay, so that previously we have seen that in case of the return 0, I have said that if it is the correct form of that, then it is 1, but here it is 0. The correct form of that, it is 0. So why I'm saying that correct form of that, it is for actually making that drawing easier. Okay, that you should need to be use this symbol. So correct form of z is 0, and the reverse z is going to be 1. Okay, so now you can see that, I mean, it's starting that the data has been given 0 1 0 0 1 1, so it is 0. So if it is 0, that is going to be correct form of z. So you can see that halfway it comes. And
স্যার ডেটাগুলো কি কোশ্চেনে দেয়া থাকবে না?
yeah, okay. If it's not given, then how you're going to draw this? Okay, so you are drawing that for 0, correct form of that. Now you are going for that the 1. So that 1 is that your correct the reverse form of that. You are getting 0. That you are getting here that correct form of that. You are getting 0 again, so that is the correct form of that. Now you have to just simply connect it. And again you are having the 1, so it is going to be the reverse z. Okay, so that is actually the reverse z, and again you are getting that the 1, so that is also going to be the reverse z, and then you have to connect it. Do you know do you understand that how you have to draw it?
Yes, sir.
Yes, sir.
Right. So if it is a differential Manchester, then you should need to be use these I mean symbols. Okay, so it is similar like that. If it is 0, represent as the z, correct form of z, and that reverse z, it can be any one of them. With that, actually it has been added this line only. Okay, with the reverse 0 and correct form of z, correct form of z and reverse z. With that, a line actually bar has been used. So you can use any one of them when you're starting, but later on, I mean, you should need to be match it with that the previous form of the signal. So here, if it is for the 0, it can be this one or this one. If it is 1, then the correct form of z is going to be 1, and reverse form of z is going to be also 1. So it can be any one of them, depend on the situation. So let's check that it is going to be clear here. uh, so you can see that here we have started the this is my 0, so we have started with this one. Okay, so you can start with anyone, is fine. If you're starting it with this one, that is also no problem. So you can start it with anyone. of these two. Okay, so now we have started actually with this one, so you can see that this is that the symbol I have used. So now you are coming here, and the next bit is your 1. So 1 can be either this or that. So check that with this position, which one is actually matching? Is that the correct jet, that form of jet, or reverse jet? Which one?
Correct that.
Right, correct form of jet. So this one actually is going to match. Look that we
Sir,
have
first one.
first one. So now you are getting 0. So if you're getting 0, now check that from this position, which one is going to be matched? This one or this one? Which one for the 0 out of these two?
Sir, first one.
Right. So that is what we are drawing the first one.
Sir, first one.
Right. And then when you're coming here, then you get again 0. So which one is going to be matched? Again this one. Okay, so you're drawing this. And then which one is going to be matched? That is the 1, right? So 1 for which one is going to be matched? The correct form of jet or reverse jet? Which one? First one or second one?
So second.
The
Sir,
second
second.
one, right? So this is the second one we're applying. So now you're having the 1 again. So from here, from this point, which one is going to be matched? First one, right?
Sir, first
This
one.
one. Right. So this is how you are actually drawing this. Clear that how to draw that? I mean the Manchester and differential Manchester encoding.
Yes, sir.
Yeah, it's easy actually if you're practicing at your home, and actually if you are learning the symbols, memorizing the symbols, then actually it's easy to draw. Okay, whatever the
Sir,
data is. Yeah.
Yes, sir.
স্যার ডিফারেন্সিয়াল ম্যানচেস্টার ক্ষেত্রে কি স্যার মানে দুইটাই সেম সিম্বল নেবো 0 আর 1 এর ক্ষেত্রে? আই মিন
Same symbol means.
মানে স্যার যদি 0 তে রিভার্স জেট নিই তাহলে কি 1 এর স্যার কারেক্ট ফর্ম অফ জেট নেব?
So when you're starting the signal, for example, this signal has been started here with this, right? Okay.
Yes sir.
With this one, it has been started. So if you're starting with this one, that's fine while you're starting. But after the first phase, after the first beat, the second beat you're receiving, on that time you have to match that what you have done, this one or this one, the next which one is matching, that you have to find it out. Do you understand that? According to the matching, you have to draw that. Clear or not?
Yes sir.
Yes, sir. Sir,
Yeah.
we can only choose the first time. After
Yeah,
that, the
yeah.
other one is.
According to that, according to the demand. After that, according to the demand, you have to take, right?
Yes.
So then
Yes, sir.
that's why actually I have given here another example here. So you can see that for the differential Manchester, in this case, it is started with this one, right? In this example, we have started with this one, right? But in this example, look that we have started with this one. Okay, this is that actually this is the fact actually here, the 0. Do you understand that or not? So you can choose. I mean, if you're starting with this or this, anything is going to be correct. But after that, you should need to be match according to the 0 and 1. You should need to be match that which one I should choose. Is it clear?
Yes.
No, right. 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 Exactly. Exactly. Yeah. So these are the Manchester and differential Manchester. And yes, practical uses of this coding, Manchester and differential Manchester. So Manchester code has been specified in the IEEE's standard 802.3, that is for Ethernet, for baseband coaxial cable and twisted pair bus of local area networks. And Manchester encoding is also used in IEEE 802.4 standards, that is the token bus. And the differential Manchester is specified in IEEE 802.5 standard, that is for token ring local area networks and used for many other applications like magnetic tapes and that the optical storage. So these are the use of that the Manchester codings, Manchester and differential Manchester coding schemes. And now if you're going to that the last one, that is the bipolar, we have talked about unipolar, polar, and now we are moving to the bipolar. So what is the bipolar is doing? It is actually using 3 voltage levels. One is positive, one is negative, and one is 0. So the voltage level for one data element is at 0, while the voltage level for the other element alternates between the positive and negative. So this is a different concept. So you can see that it has actually two concepts. One is that AMI, alternate mark inversion. So in case of AMI, you say that a neutral zero voltage represents binary zero. A neutral zero voltage represents binary zero, but binary ones are represented by alternating positive and negative voltage. Okay, so that you have to understand. Now you are going to understand it by that the graph, and for that the pseudo ternary. If the bit 1 is encoded as 0 voltage, the bit 0 is encoded by the alternative positive to negative voltage. So if you're just comparing these two, what it is telling, in the case of AMI, it said that if it is 0, then it's going to be the neutral 0. And in the pseudo ternary, it is saying that if it is the bit 1, that is going to be considered as the 0 voltage. So that is the difference. In case of AMI, it is telling that if I'm finding 0, I'm going to be considered as a neutral 0. And in the pseudo ternary, it is in that if I'm finding the bit 1, then I'm going to be encoded as it is a 0 voltage. So that is the difference actually between these two, and that is definitely that opposite bit is going to be alternating positive to negative voltage is same. So if it is 1, in case of that the AMI, then it's alternative positive to negative voltage, and in the case of pseudo ternary, if it is 0, then it's actually encoded alternative positive and negative voltage. So let's see that these two approaches, that is going to be clear from this graph. So in case of alternative mark inversion AMI, you can see that it started with 0. So if it is 0, if in the AMI it said that neutral 0, so you can see that it's neutrally progressing, and then you are getting that the ones. So it said alternative positive and negative voltage. So the first one said that we are taking it as a positive one, and then we got the 0, so it is going to be neutral. Again we got the 0, neutral. So now you get again 1. So look that the first one you have taken as a positive. So now actually you are going to be move to that the negative. So you are going to that the negative, and you are getting the 0. You are going to be moved neutral. So that you got the 1 here again, another data. So definitely it is going to be positive, because it was in the negative here. So it is that the positive here. Next time 1 you got, that goes to the negative voltage, and again you have gone the 1 from the negative. It was negative, so you are going to that the positive. Is it clear? What is the AMI?
Yes, sir.
Yes, sir.
Right. So now if you are go to the pseudo ternary, so if you are going to that the pseudo ternary, what is happening in that case is say that if the bit 1 is encoded as 0 voltage, okay, so if it is getting 1, then it is going to be moved with that the neutral voltage actually, or 0 voltage, and if it is 0, then it's going to be alternating positive positive and negative voltage. It is going to be encoded by alternating the positive and negative voltage. So we are starting with the 1, so we said positive to negative, so we started with the 0 it is. So he said that if 0 is going to be, then it's going to be alternating. So we are starting from positive for the 0, and then we got a 1. So he said that if it is 1, then it is going to be 0 voltage or neutral voltage. So it is moving for 1 as a neutral. So now you're getting 0. So it was, you started with positive for the 0. Now it is going to be moved to the negative. So now you can again get the 0. So it was negative. Now you are moving to the positive. So now you got 1. So it is going to be neutral. So now again you are getting 0. So it is going to be, it was in positive, so you're going to that the negative, and then if it is 1, then it's going to be neutral, something like that. Clear or not?
Yes, sir. Clear.
Okay, so this is the last slide for that. I mean, you CSE 465. So we are finishing the lectures here. So you should need to be practice all these graphs with their, I mean, for each of the schemes, you should need to be practice these graphs, okay? And you should need to be understand them, that actually how you should need to be draw these signals, okay? That by following that these encoding schemes. Is it clear?
Yes, sir.
Yes, sir.
I have been a bit fast today. Okay, so it's quite understandable that today is the last class, and tomorrow, as you have requested, tomorrow is going to be that the review class. Okay, now we are going to have a review class, and day after tomorrow, we are going to have that I mean consultation hour. Okay, so. I think
স্যার সবার ক্লাস শুরুর প্রথমে জানি স্যার বললেন কোন লেকচারে জানি 38 পর্যন্ত স্লাইডটা পড়াইছিলেন স্যার, ওই লেকচারটা একটু দেখানো যাবে?
yeah, sure. Okay, so I want to go this one, and you want to see this one. This one, yeah.
স্যার এটার প্রথম থেকে একটু দেখান স্যার।
It has been said that you should need to be find out the link utilization or efficiency of stop and wait protocol through that the given information. So you know that for efficiency you have seen that the formula here itself. So for stop and wait it was eta
জি স্যার, জি স্যার।
1 divided by 1 plus 2x. So that the formula you are going to be used. So you need actually that the x value. Okay. And to find that the x value, that the formula is x equal to tp by tt. So that means you have to find that tp value and tt value. So if you're getting this, then you can do the division tp divided by tt, then you will get that the x value. So if you get that the x value, then actually you'll be easily find out that what is going to be the efficiency eta equals. So to find that the tp and tt, so we are using this formula here, that for the transmission delay tt, it is going to be the packet size divided by bandwidth. So that the packet size is 1 kilobyte that has been given here, and then the bandwidth has been given here, is that the 1.5 mbps. Okay,
Yes sir,
so
please.
you can easily find out that what is the transmission delay, and the propagation delay is the round trip time divided by 2. So you have given the routing time, that is actually 45 millisecond here. So 45 divided by 2, you have got that the tp. So now actually you just simply place that the value, tp's values and tt's values that you have found. You are doing that the division, you are getting 4.12. So now it's easy for you to find out the efficiency, right, by placing that the x value. So that finally you are getting that the 10.8%. Okay.
Yes sir.
Right. Okay, so what I wanted to say is that the today's the things we have discussed, I'll ask you to practice this, all of that digital to digital and putting schemes at your home. And yes, if there is any issues that you found that you did not understand, then actually we can actually bring that discussion tomorrow or day after tomorrow again. Okay.
ওকে স্যার।
স্যার ডে আফটার টুমরো দিলে ভালোই তো স্যার, কালকে একটু পড়ালেখা কইরা তারপরে আসতাম যদি স্যার।
Yeah, that is what I'm saying. Actually, tomorrow we are going to be have a class. I was beginning of today's class that I have said that tomorrow 8 p.m. I was actually wrong. It is going to be day
Yes,
after
sir.
tomorrow. After tomorrow at 8 p.m. Okay.
Okay
And
sir.
tomorrow we have the class that is going to be actually the review class. Okay. That whatever that the things you are going to be asking me, that I'm going to be revise it tomorrow, as well as in the consultation hour, that on there also we are going to be discuss. Okay.
Okay, sir.
Okay sir.
Yeah.
স্যার আমাদের 12 তারিখে ল্যাব কি 9টা থেকে হবে?
Yeah, so that your lab exams time, I think we can make it from 9. Okay, that is going to be good for the students, because some of the students are having exam at 1 p.m. Okay.
Yes, sir. I have also from 1 p.m.
Yes, sir. I have another exam.
Sir, I have also another exam.
Yeah, so that is what I'm saying, that we are going to start